Okay, where am I? Right here. Okay. Plug in 0. I did the same problem with the other class. I like this problem very much. So plug in 0, I got 19. Plug in 10, I got 28.8. So I just copy 28.8 minus 19 divided by 10. 28.8 minus 19 is 9.8 divided by 10, which is 0.98. Without measurement unit, it means nothing. What is the measurement unit? It's a ratio. And the measurement unit must be a ratio of 2 other measurement units. So when you call me, I mentioned that before, you call me, I'm driving somewhere, and you say, tell me your speed. I will not say I'm driving at 60 miles because it's a rate of change of distance with respect to time. I will say I'm driving at 60 miles per hour. So what is the measurement unit for 0.98? Exactly. Perfect. The measurement unit for the top is inches. The measurement unit for the bottom is months. So what do we conclude? That girls between birth and 10 months old, it appears that they grow or roughly 1 inch per month. Awesome. Very good. Question number 4. Use the model to find the average rate of change in inches per month between 50 and 60. So I want average rate now between 50 and 60. Round to the nearest tenth. Okay, very good. So again, the same thing. Bless you. F of 60 minus F of 50 over 60 minus 50. I have the numbers for you. I plugged them in. Here they are. 43.012 and 40.92. I copied them. 43.01 minus 40.92 divided by 10. So this is 2.1 over 10.21. Without a measurement unit, it means nothing. And the measurement unit is? Yes? So what do we conclude? That between 50 and 60 months old, they grow at a much lower rate. This possibly almost 5 times smaller, right? So if you multiply this by 5, you roughly get that. Okay. Last question. How does this compare with your answer in part C? We already mentioned that. How is this difference shown by the graph? So the graph is something like this. Up 19, right? So 10, 20, 30, 40, 50, 60. So between 0 and 10, look how fast, look how steep the slope is, which is the average rate, almost an inch per month. But here is 50 and 60. And the slope here is much smaller. The slope here is 0.21. The slope here is almost 1. And that's how it's shown on the graph. Any questions for me? Any questions? I have your classwork, but if you have anything for me, any questions, you would like to review anything before we do that? Is there anything that you can say from last time? I would like to see blah, blah, blah. Yes, please.
How did you get 43.0?
Say it again.
How did you get 43.01?
Oh, did you put in the calculator?
That's what I got both.
So go to y equals and put in 3.1 times the square root. Do square root right here. and then x. That's the key, and then go outside of the square root, plus 19. Very good. So now we go to second and table set, and make sure that the first one is in the ask mode, just the independent variable. Enter. Good. Now we go to second and table, and put in all those numbers. 0, 10, bless you, 50, 60, 48, and all the values are there for you.
Thank you.
My pleasure. Any questions? Is there anything else? Do you have anything else for me? Yes, Damon? Yes.
One question on the last topic this year.
So you want to determine the slope?
Yes.
Okay, very good. So give us two ordered pairs. I mean, we determine the slope here. It's y2 minus y1 over x2 minus x1. This is the slope. Let's do another. Just give us two ordered pairs. Any ordered pairs you want. 3. Okay. -2, -1. Okay, very good. So the definition of the slope is m equals y2 minus y1 over x2 minus x1. Rise over run. Is that okay? I'm going to label the points as x1, y1, and x2, y2. And just put them in. -1 minus 5. -2 minus 3. Is this okay? So the top is -6 and the denominator is -5. When I divide two negative numbers, the outcome will be, so that's the slope. Is that what you had in mind? Okay. Sure. Anything else? Okay, so let's work on this. And please stay if you have any questions. Yes. Only because I guess they had a yes.